Good morning, students. Chapter 7, System of Particles and Rotational Motion. Yes, we will see some questions today. Here it is. First, a disk rolls without slipping with constant velocity. What fraction of total kinetic energy of the disk is in form of rotational kinetic energy? First of all, understand question. Okay. Disk is rolling without slipping with constant velocity. Okay, rolling motion is combination of linear motion and rotational motion. So yes, total kinetic energy is equal to linear kinetic energy plus rotational kinetic energy. But what is your question? What fraction of total kinetic energy of the disk is in form of rotational kinetic energy? Means what you have to find? You have to find rotational kinetic energy divided by total kinetic energy. This ratio you have to find. Understand meaning? What fraction of total kinetic energy is in form of rotational kinetic energy? Okay, so yes, you have to find two things: rotational kinetic energy and total kinetic energy. Okay, how to find? Actually, we have one relation, we have one equation. A total kinetic energy is equal to linear kinetic energy plus rotational kinetic energy. Okay, so is equal to linear kinetic energy, its equation, it is half mv square, plus rotational kinetic energy, its equation, it is half I omega square. Okay, so is equal to, it is half and v square plus half I disk. You are given one disk. And for disk, what is equation of moment of inertia? For disk, equation of moment of inertia is m r square by 2. Simple. Omega, we know one relation, V is equal to omega r. So omega is equal to, it is V upon r. So I can write it is V square upon r square. Clear about it? Okay. Now this r square cut, this r square cut. Okay. So I can write this as 1 by 2 mv square plus 2 into 2 is 4. It is 1 by 4 mv square. Any doubt? Any doubt? Okay. Okay. So is equal to, it is equal to, it is. Now how to find this? Yes, if you can take cross multiplication, then it is method. So it is 4 mv square plus 2 mv square means it is 6 mv square divided by 8. So you can also write this as, it is 3 by 4 mv square. Yes or no? Yes, it is 3 by 4 mv square. Clear? Okay. 4 mv square plus 2 mv square. So 6 mv square. 4 into 2, it is 8. Okay, 3 into 2, 4 into 2. So it is 3 by 4 mv square. So what is total kinetic energy? It is 3 by 4 mv square. Now what you have to find? You have to find rotational kinetic energy upon total kinetic energy. Then how to find this? See, here it is. Rotational kinetic energy divided by total kinetic energy is equal to rotational kinetic energy. See, you do not have to find separately rotational kinetic energy. See, it is rotational kinetic energy. Half I omega square rotational kinetic energy. This term rotational kinetic energy. So this 1 by 4 mv square, it is nothing but rotational kinetic energy. So yes, I can write this 1 by 4 mv square rotational kinetic energy divided by, what is total kinetic energy? It is 3 by 4 mv square. It is 3 by 4 mv square. So this by 4 mv square cut, and your answer is, it is 1 by 3. Yes, your answer is, it is 1 by 3. Simple. And doubt? So yes, it is one easy question. Another question is possible. The same question. Okay, what fraction of total kinetic energy of the disk is in form of linear kinetic energy. Linear kinetic energy. Then what you have to find? Linear kinetic energy upon total kinetic energy. And what is answer that you have to find? And what is answer that you have to find? Okay. So yes, it is one easy question. Yes, you have to understand what is question. What fraction of total kinetic energy of the disk is in form of rotational kinetic energy means you have to find ratio of rotational kinetic energy and total kinetic energy. Yes, your answer is 1:3. Okay, now next question. See what is next question. 4 spheres, each of mass m and radius r, are placed at the corners of a square having side A. Find mi. Mi means moment of inertia. Okay, mi of system about an axis along one of the sides of square. See, first of all, I will draw figure. Here it is a square of side A. So yes, it is a square of side A. Side A. A square of side A. 4 spheres, each of mass m. 4 spheres, each of mass m, are placed at the corners. Okay, you are given 4 spheres, each of mass m and radius r, which are located at corners. Okay, so yes, you have to find what is moment of inertia of the system about an axis along one of the sides. First of all, I will give name. Let it is A, B, C, and here it is D. Okay, A, B side, BC, CB, and here it is D. Your question is find moment of inertia of system about an axis along one of the sides. One of the sides. If it is symmetrical system, so if you take any side as axis, your answer will be same. Okay, here I am taking this AB side. Okay, about an axis along one of sides. So here I am taking this axis. See, here it is. I am taking this axis, which is passing from side A. So yes, you have to write. Okay, take side. Okay, let axis is passing from side A. Let axis is passing from side A. Clear about it? Yes, axis is passing from side AB. Okay, about this axis, now we have to find moment of inertia. See, we know that if you are given one sphere like this, if you are given one sphere like this, and if it is axis, then say this axis is along its diameter and it is passing from its center of mass. Then for such a sphere, if axis is passing from its center along its diameter, then equation of moment of inertia I is equal to it is 2 by 5 mr square. It is 2 by 5 mr square. Clear? Yes or no? Yes, we know this equation. But when axis is passing from its center along its diameter like this. Okay. Here in our problem, you are given 4 spheres total, A, B, C, and D. We have assumed that axis is passing from side A. So in this axis, this dotted line is axis. This dotted line is axis. Okay. So we have to find total moment of inertia of system. Total moment of inertia of system is, first of all, find moment of inertia of side of sphere A about this axis. Moment of inertia of sphere B about this axis. Moment of inertia of sphere C about this axis. moment of inertia of sphere D about this axis? Yes or no? Yes, it is. Okay, so first of all I will find individually. Okay, the moment of inertia about given axis for first sphere A. First sphere A. Chalo, for IA. See, we have to find about this axis, and see this axis is passing from its center and from its diameter. Yes or no? This axis is passing from its center and it is along its diameter. So simple. Yes. For sphere A, what is moment of inertia? It is 2 by 5 m square. Simple. Okay. Now for sphere B. For sphere B, IB. About which axis you have to find moment of inertia? About this axis. And see this axis is again, it is passing from its one of diameter and it is passing from its center. So as this line of this axis is passing from sphere A and B, for they both equation is same, that is 2 by 5 m square. Okay. Now for sphere C, you have to find moment of inertia about this axis. Yes, this axis. And sphere C is here. Sphere C is here. We know that if it is diameter of sphere C, then about this axis what is equation? It is 2 by 5 m square. But we have to find about this axis. See, these two axes are parallel to each other. Okay, so yes, if it is 2 by 5 m square, but we have to find with respect to this axis. Then how to find? Yes, with the help of parallel axis theorem. Okay, IC is equal about its own diameter. It is 2 by 5 m square plus md square. So it is m. D is replaced by A because between these two axes, what is distance? It is A. So it is A square. So see its difference? It is difference. Okay, to find moment of inertia of C about this given axis, you have to use parallel axis theorem. And if you understand how to write equation for C, you can easily write for D. It will be same. Okay, for sphere B, for sphere D, ID is equal to, chalo, ID, if it is diameter of sphere D, about its own axis it is 2 by 5 m square, plus you have to find with respect to this axis. These two axes are parallel to each other, so it is m a square. Clear? So yes, individually IA, IB, IC and ID. If you have assumed that axis is passing from this side CD, then yes, IA, IB and IC, ID, they are interchanged. Yes or no? Yes, yes. Okay. So yes, IA, IB, IC and ID. Now we have to find what is total moment of inertia of system. So total moment of inertia of system about given axis. I is equal to, it is IA plus IB plus IC plus I. Okay, is equal to, chalo simple, IA, IB, IC and ID. See, 2 by 5 m square plus 2 by 5 m square plus 2 by 5 m square plus 2 by 5 m square. So I can directly write it is 4 into 2 by 5 m square plus m square plus n square, means it is 2 m square. Simple, means it is 2 m square. Now I can take 2m common. So if I am taking 2m common, here it will be 4 by 5 r square, and here it will be only square. Clear? So yes, it is one question which is based on moment of inertia. Most important thing is about which axis you have to find moment of inertia. About which axis you have to find moment of inertia. Clear? So yes, there are two questions based on moment of inertia, and yes, it is based on rolling motion. Clear about it? Now next question, see, find the angular momentum of Earth due to Earth's rotational motion about its own axis. Mass of Earth m is equal to 6 into 10 raised to 24 kg and radius r is equal to 6400 kilometer. Yes, kilometer means you have to convert. It is equal to radius 6400 into 10 raised to 3 meter. Okay? Okay. Or you can also write this as 1, 2, 3. So it is 6.4 into 1, 2 and 3. So it is 10 raised to 6 meter. Okay. Now yes, you have to find angular momentum. So angular momentum L. Its equation is L is equal to I omega. So yes, you have to find what is I, that is moment of inertia, and what is omega. So yes, here we will find separately what is I and omega. I, that is moment of inertia. Earth behaves as a sphere. Earth behaves as sphere. So its moment of inertia I is equal to this 2 by 5 m square. So this equal to it is 2 by 5 m. So what is value of m? It is 6 into 10 raised to 24. R, it is 6.4 into 10 raised to 6 whole square. Okay, so is equal to is equal to, now how to calculate this? See, it is simple. This, okay, 2 into 6 into 6.4 into 6.4, okay, divided by 5. Divided by 5. So it is 98.305. Okay, again I will recheck it. Okay, 98.34. Remember, 2 into 6 into 6.4 into 6.4 is equal to divided by, it is 5. So yes, I am right. Here it is 98.304 into, what is power? 10 raised to 24, 6 into 20 is 12. So it is 10 raised to 24 plus 12. 24 plus 12, it is 36. It is 36. Clear? So it is kg meter square. Okay. Now another thing we have to find, that is omega. What is omega? Omega is equal to 2 pi t. Yes, you know its equation. Omega is equal to, it is 2 pi upon t. T means time period. Okay, so yes, it is time to complete one rotation about its own axis. What is time to complete one rotation about its own axis for Earth? Yes, it is 24 hours. Yes, it is 24 hours. So yes, as time t, you have to get 24 hours. Here, t is equal to 24 hours. Now 24 hours means 24 hours is equal to, it is 24 into 3600 second. Simple. 24 into 3600 second. Then how to find it? See, it is 2 into 3.14 divided by, it is 24 into 360. So here is equal to, it is 2 into 3.14 is equal to divided by 24 is equal to divided by 3600. Divided by this 3600. Then how to find this? Again, it is 2 into 3.14 divided by 24. So it is 0.262 divided by, it is 36 is equal to, it is 0.007. 0.007, and yes, these two zeros. This is 100. So is equal to is equal to it. See, it is called 7 into 10 raised to minus 3. And this 2, so I can say it is 7 into, it is 7 into 10 raised to minus 3 and divided by this 10 raised to 2. So is equal to, I can say it is 7 into 10 raised to minus 5 radian per second. Radian per second. Clear about this? Okay, so yes, it is how to find this omega. Now you have to put values here. Okay, L is equal to what is value of I? It is 98.304 into 10 raised to 36 into what is omega? It is 7 into 10 raised to minus 5. So is equal to 98.304 into 7. So is equal to it is 688.128 in what is power? 36 minus 5, it is 10 raised to 25. Sorry, 36 minus 5, so it is 10 raised to 31. It is 10 raised to 31. Clear about this? Clear about this? So it is how to find moment of inertia. It is how to find moment of inertia, angular momentum, and yes, it is angular momentum. That is L is equal to this 688.128 into 10 raised to 31. 688.128 into 10 raised to 31. Okay, you can also write this. If I am taking this 2 by this sign, then it is 6.88 into 10 raised to 30. 2 points we have moved. Okay, so it is 6.88 into it is 10 raised to 33. 10 raised to 30. Clear about this? Okay, its unit, angular momentum, its unit. What is unit of angular momentum? What is unit of angular momentum? Angular momentum is equal to it is linear momentum into distance. Angular momentum is equal to it is linear momentum into distance. So yes, how to write its unit? What is unit of linear momentum? Linear momentum, P, or you can say it is MVR. M is kg, meter per second. Here it is meter. So it is kg, meter square per second. Okay, it is how to remember some units. Clear about this? Okay, so yes, it is one question which is based on again equations and calculations. Okay, now the next question. See, chalo, what is next question? We will see. Okay, next question is, see, initial angular speed of a wheel is 20 radians per second. Its angular displacement is 10 seconds in 100 radian. How many revolutions it will make from the beginning to the time till it stops? Find its angular acceleration also. See, first of all, we will write here. Initial angular speed omega 0 is equal to 20 radian per second. Its angular displacement in 10 seconds, t is equal to 10 seconds. Angular displacement means theta is equal to 100 radian. Okay, how many revolutions it will make from the beginning to the time till it stops? It stops means omega is equal to 0 because it stops. Okay, revolution means numbers of revolution you have to find, and find its angular acceleration means alpha is equal to question mark. Means alpha is equal to question mark. Okay, so alpha is question mark. Okay, yes, we can easily find. First of all, we will find alpha. How to find alpha? Yes, we know equation of alpha. Okay, alpha is equal to it is omega minus omega 0 upon t. So alpha is equal to 0 minus 20 divided by time is 10 seconds. Okay, so alpha is equal to it is minus 2 radian per second square. Alpha is equal to it is minus 2 radian per second square. Simple? Yes, it is. Then you have to find numbers of rotation. So see, we know one relation. Okay, if angular displacement is 2 pi radian, that numbers of rotation or revolution 1. Okay, here you are given angular displacement 100 radian. Then for 100 radian, numbers of rotation question mark. Okay, so therefore n is equal to this 100 upon 2 pi into 1. So 2, here it will be 50. So therefore n is equal to it is 50 upon 5. N is equal to it is 50 upon 5. Clear? So yes, it is one easy question. Okay, so yes, only 4 questions for today. Yes, this is it for today.